Welcome to the first video in the entity routing module. As for the objectives for the module, we're first going to talk about the basic concepts related to entity routing, namely entity destination and outbound link selection. Once we're familiar with these fundamental concepts, then we can go ahead and learn the different types of routing and how we can implement them in Simio. So specifically, we're going to talk about probabilistic routing. We will talk about conditional routing, where we need to make a set of decisions before we select or figure out the destination for an entity. We will talk about the cases where we have compound, probabilistic, and conditional routing. We will also talk about dynamic routing using a node list. So an example of dynamic routing is when you enter a restaurant and you pick the shortest line. So you pick the cashier that has the shortest line. This is a decision that you make in real time, and the cashier you select really depends on the state of the system at the time you enter the restaurant. We will also talk about routing with sequences, which relates to the cases where we know the sequence parts or entities visit different nodes or objects in the model. So an example of this situation is a manufacturing system where we have multiple part types, and each part type visits the machines in our manufacturing system in a predetermined sequence. So in terms of what will be covered in each video in the module, we're going to talk about the basic and fundamental concepts in the first two videos. We will discuss probabilistic, conditional, and compound probabilistic and conditional routing logic in the third video of the module. The fourth video involves dynamic routing using node lists, and finally, sequence tables are discussed in video 5. Also note that there are two related topics: routing using task sequences and writing on transporters, that are not covered in this module and will be deferred to future modules. So here is a flowchart of the specific topics covered in the module. And as you can see, for entity destination, we have two possibilities. Our entities either have a destination node set or they do not have a destination node. In the first video of the module, we look at the case where our entities do not have a destination. So we talk about the default behavior when we have free space movement, in which case the entities will simply select the closest external input node in the 3D space. For the case where we have a network of link objects, in other words, paths, connectors, conveyors, we look at the case where we have a single outbound link out of our transfer node, in which case we do not really have any options to choose from. If we have multiple outbound links, we can either specify a specific link for our entities to take, or we can use the selection weight property of our outbound links to perform probabilistic and conditional routing. The second video of the module involves the general case where the destination node for our entities is either set or will be set at some point during the run. We'll look at the case where we specify a specific node as a destination node for the entities, either using the entity destination type property of the transfer node or the set node step. And we'll look at different combinations of the outbound link preference and the outbound link rule properties of the transfer node. We briefly talk about routing using Simio processes and transfer step, and also the steering behavior, which is the free space flow around a path. This is particularly useful in agent-based modeling and specifically for modeling crowd movement. In the third video of the module, we have a closer look at using the selection weight property of our outbound links for probabilistic and conditional routing, and we also cover compound probabilistic and conditional expressions for the selection weight property. The fourth video of the module involves dynamic routing using node lists. So in this case, we dynamically select the destination node of the entity based on the current state of the system from a list of candidate nodes. And finally, in the fifth video of the module, we talk about routing using sequences where the entities need to visit a predefined or predetermined sequence of nodes or objects in the model. And we see how we can use sequence tables with a network of link objects or free space movement. So let's go to Simio and talk about the basic concepts related to entity routing. So here is my facility view, and we know that this is a 3D space where every object and entity has a location associated with it, and as entities move in this 3D space, their location along the X, Z, and Y dimensions changes. In the standard library, we have four types of link objects. So when you use a connector object, the transfer time is 0 simulation time. So the entity gets transferred from the start point of the link to the end point of the connector in 0 simulation time. When you use a path object, the transfer time depends on the length of the path and also, of course, the speed of the entity. When you use a time path, you can set the transfer time. So this is something that is specified by the user. And we also have the conveyor object definition that we can use to simulate conveyors. So these four object definitions are what we call link objects. Also note that additional links supporting continuous flow can be found in the flow library. So we have the flow connector and pipe, but these object definitions won't be discussed in this video. And in Simio, there are two types of nodes that support connection between these link objects. So we have the basic node and we have the transfer node. So let's talk about these two nodes before we talk about entity routing. So let me grab a basic node and put it on my facility view. So here on the right you can see different properties of my instance of the basic node object definition. So we have the traveler capacity, which is the number of traveling entities that can simultaneously occupy this node. We have the entry ranking rule that determines the order in which the competing entities can enter this node. We also have a set of properties related to routing logic, and for the basic node we have the outbound link preference, and we have a few options for the outbound link preference. We have any, available, and specific, and we also have the outbound link rule, and for this property we have two options, which are shortest path and by link weight. We can also enhance the logic of our basic node by defining add-on processes. Now, a transfer node, on the other hand, is a more comprehensive node that has all of the capabilities of a basic node, but it also allows for setting the destination of entities. So we have this property called entity destination type that allows for selecting the destination for our entities, and its default value is continue. We can also set it to by sequence or select from list or a specific destination node, or we can also use a custom routing group. The transfer node also allows for writing on a transporter, and as you can see here under the transport logic set of properties, I have this write on transporter property that is defaulted to false, and I can set it to true, and then I have a whole bunch of properties that open up that are related to writing on a transporter object, and we can use a vehicle object or a worker object as a transporter device. However, writing on transporters is out of the scope of this module and will be covered in a related video module. So let me go back and change this back to its default value, which is false. And now I'm going to delete my transfer node and my basic node and talk about the fact that most of the objects in the standard library have either basic or transfer nodes or both of them embedded in them. So let me grab the source object here, and as you can see, the source object has one node which is a transfer node that controls how entities exit the source object. A server object, on the other hand, has, let me zoom out a little bit here. A server object, on the other hand, has two nodes, a basic node which serves as the entry or the input node of the server object, and a transfer node which serves as the output node of the server. A sync object, for instance, has only one node, which is an input node, and it's a basic node. In fact, if you notice, you will see that the entry nodes or input nodes for the objects are all basic nodes. And the main reason behind this is that we are typically not concerned about setting a destination or writing on a transporter on entry to any object. So now that we're familiar with different types of nodes, let's go ahead and talk about entity routing. So here I have this simple single server model, and I haven't changed any of the parameters, of course. So my source creates entities of type default entity, and everything else is set to its default value. So let's run this model and see what happens. So I'm just going to go to run and hit run, and immediately I get this warning that says entity default entity 9 failed to initiate transfer from output at source 1 onto an outbound link. Of course, because I don't have any outbound link currently in my model. So the entity doesn't know where to go, and what Simio does, it automatically destroys the entity. So if I continue running this model, whenever the next entity realization is trying to leave the source object, the same problem occurs, and I get the exact same warning, this time for my newly created realization. So let me pause the simulation and stop the model, and grab a model entity instance, and I'm going to reduce its speed to 1. But the property that I'm interested here is the initial network, which is defaulted to global. So whenever I add link objects to my model, these will be added to a network called global. So my default entity has this global network associated with it, and it moves in this network of path or link objects. So the other option that we have is no network or free space. And in fact, when I select this, now entities are simply routed to the closest external input node in the 3D space. So if I run the model now, as you can see, my entities will first go to the input node of the server, they will get processed, and then they will go to the sink. Now, if I add another server object instance to my model, you can see that since the input node of this server is closer to the output node of my first server, now entities will first go to the first server and then go to the second server. Then they will go back to my first server. Now if I move this server a little bit to the right, the input node of the sink becomes closer, and the entities will leave the system after they get processed on server 2. So you can go ahead and play around with this model a little bit and move the objects around and see how the flow of entity changes based on the distances between your nodes. So before we continue, let me rearrange my objects here and then reset my initial network property for the default entity to global. And now we're going to talk about how we can handle different routing logic when we have a network of link objects. So I'm going to double click on the path object definition and add a path from my source to server 1 and then from server 1 to the sink. And now when I add these links to my model, they're added to the global network, which is associated with my model entity instance. So now when I run this model, the entities will take the paths that I've just added to the model. And remember that in this model, we haven't specified any particular node as the destination node for entities leaving the source object or the server object. And in fact, when we look at the properties, the default properties of the output node of source 1, for instance, you will see that the entity destination type is set to continue. So let's have a closer look at what this continue actually means. So I'm going to go to the support ribbon and open Simio's help and search for transfer node, which is what I already have here, and list the related topics. And here you can see that there is a page on transfer node, and it talks about its different properties. There is also another help topic called transfer node discussion and examples. And on this page you will find additional discussion along with some examples related to transfer node and entity routing. So for instance, if I look at the definition of continue under the entity destination category, it says the entity will simply continue down the appropriate path leaving this node as determined by the rules mentioned above, which are the outbound link related rules that we will talk about shortly. It also says if a set node step was used in the processes window, this entity is indeed going to a specific node, but the entity destination here can be set to continue. So we'll talk about the set node step in the second video of the module, but the general idea here is that the help is a great resource to find information about how exactly Simio works and how different objects behave. So you should definitely get used to using Simio's help. And in fact, most of the topics that are covered in the first and second videos of the module are all discussed on this page in the help. So back to our model, since we only have one path leaving our transfer node, then all of the entities will take this path and continue to where the path takes them. So let me go ahead and add another path from my source to my second server and also connect my second server to the sink. And now when I run this model, what happens is 50% of the entities will be routed to the first server, and 50% of the entities will take the new path to the second server. So note that I'm using the default properties of the output node at source 1, and the way Simio determines the probabilities of taking each path is by using the selection weight property of the paths. So for path 1, the default selection weight is set to 1, and also for path 3, the selection weight is 1, so the probabilities will be equal. So let's have a look at how Simio actually calculates the probabilities of selecting the outbound link. So let me go back to my slides and have a look at this scenario here where I have two outbound links out of my transfer node, and each of these outbound links has a selection weight associated with it, and the formula that Simio uses looks like this. So the probability of path I being selected is based on its proportional selection weight. So the probability of selecting path 1 is W1 divided by the sum of the selection weights for all of the outbound links. So it'll be W1 divided by W1 plus W2. And similarly for the second path, it will be W2 over W1 plus W2. So this is how Simio determines the probability. So let's have a look at a couple of examples here. So let's say I set the selection weight of this path to 0.2 and for the other path to 0.8. So the probability of selecting the first path will be 0.2 divided by 0.2 plus 0.8, which will give me 0.2, and the probability of selecting the second one will be 0.8. Now note that as long as I keep the same proportions, I'm going to get the same probabilities. So in the next slide, I'm going to change the selection weights to 4 and 16, and note that I've simply multiplied my selection weights, my original selection weights, by 20. So I'm keeping the same proportion. And what happens is when I calculate the probabilities, I'm getting the same 0.2 and 0.8 probabilities for selecting the first and second path respectively. So let me go back to my Simio model, stop the model, and change my selection weight to, let's say, 0.2 and 0.8, and this time when I run the model, I expect 20% to take this path and 80% to take the path that goes to the second server. Of course, you can run the model and perform an experiment and verify that this is actually working. I'm going to skip this to save some time. But I'm going to show you another way to verify that the selection weight is actually working. So I'm going to set the selection weight for my first path to 0, and it doesn't matter whether I change this one or not. And this time I expect all of the entities to take this path that goes to server 2. So let me run the model and verify that actually no one will take this path that has a selection weight of 0. And in fact, if you watch the model run, you can verify that this is actually working. So one last note that I would like to make about using selection weights is that the selection weight does not necessarily have to be a numeric value. And in fact, we can have other expressions that can help us have conditional routing. So for example, let's talk about this model, which is the model that we will build in the third video of this module, where we have a model of an airport security checkpoint where we have a limit on the number of times that the passengers can be scanned or can fail the advanced imaging technology screening. So on this path that goes from the scanners to the pat-down station, you will see that my path has a selection weight that is not a numeric value, but instead it's an expression that is based on a model entity state variable. So in this case, I would like to route those passengers that have failed this scanning process a certain number of times to the pat-down station. And we will discuss this in more detail in the third video of the module. So we're still talking about the situations where our entities do not have a destination. And the last situation that we're going to talk about is when we want the entities to take a specific path. So in this case, I would like all my entities to take path 1. And of course, now we know how to do this using selection weight. So we can change this selection weight to 0 and have a non-zero selection weight for our path 1, and all of the entities will take path 1. However, an alternative approach is to use the outbound link preference, but instead of any, we can set it to a specific path. And this time, Simio pops up this error message that says, well, you need to specify which path or outbound link you want your entities to take. And in this case, I'm going to simply select my path 1 from the drop-down list. And when I run this model, you will see that regardless of the selection weights of my paths, all of the entities will take the path that I specify in my output node of my source 1. So one last thing that I would like to mention about this outbound link name property is that, similar to the selection weight, it does not have to necessarily take the name of a specific path object instance, and in fact we can have expressions here as well. So consider an example where we want to route entities to different places in our model based on the type of the entity. So in this case we can use a model entity state that stores the name of the path or outbound link that the entity needs to take depending on its type. In another example, consider the case where we want to dynamically route entities through different paths based on the state of the system. In this case, we can make the decision and then use a state variable that holds the result of the decision that we make and use that as the expression to select the outbound link dynamically. So in this video we talked about the general case where our entities do not have a destination node set, and we talked about the default behavior of the free space movement where the entities select the closest external input node in the 3D space. We also talked about the cases where we have a single outbound link or multiple outbound links, and in the latter case how we can specify a specific link for the entities to take, and also how selection weights can be used to route entities probabilistically. Also note that we will discuss probabilistic and conditional routing in more detail in the third video of the module. So in the remaining videos of the module, we're going to talk about the right side of this flowchart where the entities either have a destination node set or the destination node will be set at some point during the simulation run.